Greetings to all the viewers. Now we are going to start with the content called Atropine. The session what we are going to cover is AA powered. Here, atropine is the kind of alkaloid. It is the class of alkaloid where essentiality is the presence of nitrogen, right? So we are going to discuss about what is meant by atropine, what is its chemical skeleton, and how can we elucidate its structural complexation, and followed by how can we synthesize this molecule in the laboratory, and finally we will go with its potential applications. Let's go with the compound called atropine. Its chemical skeleton is provided over here, where we can find bicyclic system with the nitrogen in methylated nitrogen is there. And here the functionality is the ester, and we can also notice another alkyl, alcoholic side chain, and here benzene ring is present over. This is the kind of alkaloid called atropine. Atropine is the medication derived from the belladonna plant. Its scientific name is provided as Atropa belladonna and is classified as anticholinergic agent. Anticholinergic agent is meant for the drug which is acting upon the nervous system, and it works by blocking the action of acetylcholine. Acetylcholine, if secreted in the maximum extent, that used to give the neurological disorders, so that by blocking the secretion of acetylcholine, so that it used to mitigate the neurological disorders. So that we can say anticholinergic agent. It used to antagonize, means it used to suppress the secretion of acetylcholine, which can lead to the various physiological effects, so that neuro-related problems get curated by means of this drug called atropine. Here, some of the essential applications for the atropine are provided. Bradycardia. Atropine is commonly used to increase heart rate in the severe bradycardia. Bradycardia is the kind of cardiological disorder where heart pumping will become very slow, so that blood circulation, blood purification followed by circulation is becoming very low. So at that lower heart rate, we used to consume the atropine, so that it used to enhance that pumping of the blood by means of heart, so that heart rate will increased. And in either application, we can say antidote. Antidote is applied. Antidote is the medicine can be applied whenever the person who is injured by any kind of poisoning. Some heavy metals will be there, they consumed inside, they will induce some kind of diseases. At the time we need antidotes, mercury or else lead. And even here organophosphate, if consumed, that creates the poisonous impact on the metabolic activities of the human being, so that this atropine is working like an antidote. Antidote meant for which used to suppress the poisoning effect, detoxification we can say, right? So organophosphate kind of pesticides if consumed, that used to impact on the nervous system, so that we will consume this atropine as the antidote. And next is about ophthalmology. Ophthalmology related with the eye related disorders present. In that condition also atropine can be consumed. We will go with the detailed application in the next slide. Pre-anesthetic in the sense, whenever we need the surgery or else any kind of severe injury is there at that condition, during the medication, in order to pass the brain functioning temporarily, we supposed to consume the anesthetic agent. That may be a general anesthesia or else local anesthesia. If the surgery is a major, so that we have to consume the general anesthesia. Minor surgeries requires the local anesthesia. So at that condition, whenever we are going to consume that anesthesia drugs, what happens? Our entire activities get passed for. Sometimes we will be unconscious for a few minutes or else hours. Right. At that condition, pre-anesthetic agents are required. Atropine is working like a pre-anesthetic agent. Whatever anesthetic symptoms will be there, that will get mitigated by this atropine, so that Whenever anesthetic agents are consumed, there is a common symptom called salivation. So secretion of saliva is possible and respiratory secretions also possible. When atropine is used as a pre-anesthetic, so that we can minimize the secretion of the saliva, and even respiratory secretions can be minimized. This is the plant, we can say Atropa belladonna, and from this plant only we are going to extract the natural product. Being all the sessions what we are covering, alkaloids are natural products, so that plant extract it will be. So here Atropa belladonna is the plant from which we are going to extract. It's a flowers also mentioned over here. So from this the alkaloid called atropine is extracted. We will see the glance about this atropine. Its structural elucidation is going to be discussed here. Atropine has a complex chemical structure and can be described as follows. If you observe, right, if you observe its chemical composition, it is somewhat complex in nature. Much more cyclic rings are present over, and so many functional groups are located here. And in alkylated system is there, and even we have chirality over there, so that we can say it is a complex molecule, right? Let's go with the detailed description about this atropine. IUPAC name. IUPAC stands for International Union for Pure and Applied Chemistry. According to IUPAC, its name is provided as 1s3R, 1 azabicyclo, 2 comma 2 comma 2 octane 3-yle, 2s, 2 hydroxy, 2 phenyl acetate. Right? Why we are saying this much long, lengthy one means that this is called absolute configuration. Absolute denotes what? If you are mentioning exact RS notations as well in the IUPAC nomenclature, that is called absolute configuration, absolute naming system, right? So here, being it is a chiral molecule, so that we will go with its orientation effect as well, where it is located. That orientation is also mentioned in this IUPAC nomenclature. And moreover, being it is a bicyclic, so that bicyclic notations also mentioned. So that this is the systematic naming which is provided by the IUPAC nomenclature. Let me repeat once again. 1 is 3R, 1 aza. Aza denotes nitrogen, and bicyclo, 2 ring systems. If fused, that is called bicyclo. And 2 comma 2 comma 2 octane. All 2 rings are composed by 8 units of carbon, so that we can say octane. 3-yle. 3-yle is present. Yle denotes what? Our triple bonded center will be there. And 2s. S denotes what? Levorotatory system. It is moving in anti-clockwise rotation. And 2 hydroxy. At this second carbon, we are accompanied by the hydroxy. And 2 phenyl acetate, right? Phenyl acetate moiety will be there. If we are having CH3COO, that is designated as a acetate, so that we can say this is phenyl acetate moiety. This fragment is also denoted as a tropic acid moiety. Fine. This is the way entire IUPAC nomenclature. It is a complicated molecule, so the lengthy name is provided, incorporated with RS notations and the bicyclic system naming as well. Let's go with its molecular formula. Molecular formula indicates number of carbons, hydrogens, nitrogens, oxygens, sulfur, whatever present in the molecule, that number is mentioned over here. Here we have 17 carbon atoms, 23 hydrogens are incorporated, nitrogen is 1 and only 1. Oxygens are 3. If you count here, you can find 3 oxygen atoms. This is the way C17H23. NO3 is the molecular formula of this natural product called atropine, and molecular weight. There is a difference between molecular formula and molecular weight. Molecular formula represents number of individual elements present in the molecule. Molecular weight means that how many grams it weighs, right? So the entire molecule, if weighed per mole, that is 289.37 grams. So its molecular weight is mentioned as 289.37 gram per mole. This is about the fundamental features and structural features we are going to discuss about bicyclic structure. Atropine contains a bicyclic framework. Bicyclic means two ring systems are fused together, which is called a bicyclic ring system as a tropine ring. So this fragment, whatever we are mentioning with the circular manner, this is denoted as a tropine. This is called a tropine ring, which consists of a 7-membered ring system with the nitrogen atom. So the entire system, whatever present, that is accompanied by the nitrogen, which is the essential component of the alkaloid. And a 7-membered ring system is incorporated over there. And it is a tropane moiety, tropane fragment it will be. Ester functionality. Any other structural features we are discussing about ester. Wherever RC double bond O is present, that is denoted as a ester. This ester functionality is present. This is formed by the combination of one hydroxy and another carboxylic acid. It has an ester functional group due to the phenyl acetate moiety attached to the tropane structure. This phenyl acetate fragment is condensed with this tropane fragment so that the ester functionality is originated in between. Chirality. Obviously, here absolute configuration if mentioned, obviously the compound is regarded as a chiral in nature. Any compound having the carbon of 4 different functional groups around the carbon atom is mentioned as a chiral carbon, so that chirality is observed in the molecule called atropine. And two enantiomers are possible for this one. Two enantiomers denotes what? One is dextrorotatory, neither is levorotatory whenever the molecule placed in the polarimeter. If it is rotating the light in the clockwise motion, that is designated as a dextro. If it is moving in an anti-clockwise, counterclockwise rotation, called a levorotatory. But though two enantiomers are possible for this atropine, it only accompanied by the levorotatory. In general, in the nature, you can observe this atropine is a levorotatory. This is a commonly available levorotatory isomer we can find. This is only having physiological activity, whatever we are discussing for this molecule. Now, by completing all the entire structural elucidation process, we entered into the next segment called the synthesis overview. How can we synthesize the molecule called atropine? So within the laboratory also, it is possible to synthesize the molecule by starting with the tropinone. Tropinone is a naturally valuable molecule, or else it can be synthesized in a simple manner from the precursors, starting materials, and either starting materials as well, but the tropinone is taken as a starting material for the synthesis of atropine. Right, here is the tropinone, where is the 7-member ring will be there, and where bridged nitrogen is located. This nitrogen is accompanied by methylation, and at the one of the carbon edge you can notice a ketonic functional group, hence we can say one. Generally known or own is suffix you can observe whenever the molecule is accompanied by the ketonic functional group over there. So tropinone is the molecule with the 7-member ring system with the fused nitrogen. An alkylated fused nitrogen, bridgehead nitrogen is present, and at the one edge of the carbon you can notice the ketone. This will be the starting material, and upon reduction, you have to proceed with the reduction process. Whenever subjected to reduction, obviously ketone will turn into a hydroxy. This is accomplished by the addition of either lithium aluminum hydride or else sodium borohydride. In any of the alkylating agent you can go with, so that this tropinone will turn into a tropine, which is a hydroxy functional compound. The next step, that will be the last step. Whatever tropine synthesize, the final problem, we will go with the in either named reaction. We can say the tropine can be condensed with another chemical component said to be a tropic acid. So hydroxy compound, upon treating with the carboxylic acid by the process called Fischer-Spear esterification process. Hydroxy with the carboxylic acid proceeded with the Fischer-Spear esterification process, so that we can originate this ester functionality among tropine fragment and tropic acid functional group. So this is the way we can go with, and in order to proceed this reaction, here is the reaction condition mentioned. Acid conditions are required, so that we added with the slight amount, a little amount of hydrochloric acid, so that final product atropine was synthesized. So whatever atropine synthesized is in crude manner, and any side products may also accompanied with that, so that next process is for purification. The resulting atropine can be purified through the crystallization or else chromatography. Crystallization is possible whenever compound is dissolved in the suitable solvent, so that whatever atropine is there, that dissolved into the solvent, and undissolved components will be separated by simple filtration process. You can go for the evaporation, so that a crystalline compound of the atropine will be collected in the pure form, or else chromatography. Chromatography is also the technique for the separation of the components based on the rate of adsorption, rate of diffusion of the components. You can collect the atropine at particular instance, so that purified compound will be collected by the chromatographic technique as well. Most commonly, column chromatography is applied over there. Summary of the reaction steps. After getting purification, so a simple glance about what we are doing for the synthesis of this atropine. Starting material is a tropinone, where the ketonic compound was taken and simply subjected to the reduction process, either by lithium aluminum hydride or else sodium borohydride, and we will get hydroxy compound called tropine. The tropine get condensed with any acetyl chloride, or else this is a compound called tropic acid, and atropine will be synthesized. This is the process called esterification. Esterified compound is called atropine. This is about synthetic overview of this atropine. And the last segment of the session will be how can we apply. We are extracting the product from the nature, or else we are synthesizing the same compound in the laboratory. After doing all these things, what is the use of this compound actually? Without the usage, the compound may not have any sense. That's the reason why we have to go for its applications. Atropine have several important applications in the medicine and even in the other fields as well. Here are some of the primary uses are quoted over. Medical applications, cardiac use. Just now we mentioned about cardiac usage. Whenever atropine administered, whatever slow pumping of heart will be there, that get enhanced, and heart pumping rate will be increased, which is called decreasing bradycardiac effect. Bradycardiac effect will be, sorry for the interruption. We are discussing about the cardiac usage of this atropine. Bradycardia is the disease where the patient is suffering with the low pumping of the heart, low heart rate will be there. Whenever atropine got consumed, what happens? It enhances the heart working rate, so that what heart pumping rate will be enhanced by means of this atropine. Antidote for the poisoning. Just now we discussed antidotes are majorly used for the toxicity by means of any severe hazardous compounds whenever consumed inside. Organophosphate consumed, what happened? That used to induce poisoning in humans, so that metabolic system entirely damaged, so that antidote for that will be a atropine. Atropine can be applied in order to detoxify the effect of organophosphate. This is the kind of pesticide we are using over. And nervous system abnormality will be managed by means of this atropine. Ophthalmology. So ophthalmology indicates what? Whenever any people are suffering with the eye related disorders, at that condition we have to go for the usage of this atropine. How can we utilize? Let's see. Pupil dilation. Pupil means the part whichever present inside the eye, the circle, the ball, what we are observing over, that is called a pupil. So that whenever we require surgery or else any kind of examination, at the time pupil enhancement is required, dilation in the sense that we have to go for pausing its effect for some time, blinking, everything we have to pass, that is called dilation of the pupil. Whenever the eye examination required, at the time atropine drops will be used in order to dilate the pupil so that its size got enlarged, and examination becomes very easy for that. So here pupil dilation, we can say that at that condition we can apply the atropine. Cycloplegia, temporarily paralyzing the ciliary muscles, which can be useful in diagnosing refractive errors. So here, ciliary muscles are present in the eye. If they are not properly working, so if they are not properly working, that is called temporary paralysis for that one. So that used to give some kind of eye-related problem, ophthalmological disorder will be generated. At that condition, also we will go with the consumption of atropine for the curation. So this is the way we can apply in the various medical fields. And in either medical application, pre-anesthetic medication. Pre-anesthesia is nothing but the drug which used to suppress the activity of brain and its extended nervous system for some time. That is called anesthesia. So whenever we require the surgery or else any kind of transplantation or else any implant is required or else any treatment is required, in all these conditions we have to consume this anesthesia. So anesthesia may also accompanied by some kind of symptoms which can be minimized by means of this atropine. Atropine, if consumed as a pre-anesthetic medication during the surgery, if that anesthetic agent is giving a salivation, excessive salivation or else any respiratory secretions are there, that will be totally mitigated, that will be minimized by means of this atropine. Atropine get minimize salivation and respiratory secretions, which are the symptoms of anesthesia. Gastrointestinal disorders. If any people are suffering with the digestive system or intestinal tract related disorders, that also curated by means of this atropine. It can help to manage certain conditions like irritable bowel syndrome. So it is the kind of disorder present in this gastrointestinal tract, and reducing the secretions and the spams in the gastrointestinal tract. At that condition, also atropine consumed for the effective curation of gastrointestinal disorders. And the usage in the agricultural field, atropine can be used in the pest control system. We can minimize the disease causing pest by means of this atropine. Atropine used in the optimal dosages in order to kill the disease causing pest as well. Another important application in the research. Atropine is used in the pharmacological research to study the effect on anticholinergic agent in the nervous system. This is the actual usage of that atropine. Nerve-related disorders get curated, and here is the entire picture is provided for the nervous system. Due to its main work upon this nervous system, so that nervous system chart is provided over. Nervous system is categorized into peripheral nervous system and central nervous system. Brain and included with the spinal cord is called the central nervous system, and further extended nerves included with the millions of neurons are called the peripheral nervous system. Peripheral nervous system again categorized into autonomic and somatic nervous system will be there, and further categorization also present. So that main work, atropine mainly works upon this anticholinergic acetylcholine secretion get minimized, so that neurological disorders get mitigated by means of this atropine. So that nervous system disorders, on that research is still going on, so that it is most important component in the end. It is the class of alkaloid, and we completed the comprehensive discussion regarding the entire history of atropine, how can we extract from the plant, and what will be the structural elucidation step by step, and followed by laboratory synthesis and its effective applications. Entire informative session got carried over, and I hope the session is helpful for your information. And thank you very much for your patient listening. This is Dr. Kavita Kotireddy Kota. Thanks a lot.